Okay, so now let's take this thing and turn it into vectors, because what we want to know if it's accelerating is what do these sum of forces look like. So before I can do anything with this, and actually let's take this to a clean sheet. Rewrite this. That I have defined this. I have this force normal. It's contact between the surface and the book or the box or the whatever the heck it is. My force of gravity, that is the mass is being pulled down towards the center of the earth. And then this force applied. Whatever that force applied is, and this one we were told it's a pull, it doesn't matter. You can call it Jerry if you want, it doesn't matter. It's at 30 degrees. So before I can do any math with this, one thing I will always require, so make a note of that, is that I define for me what is positive. So this is my y-axis, this is my x-axis. If I want, I can kind of dot that in there, that this is x and this is y. And I'm going to do a sum of forces, so two-dimensional trig addition. Let's see, so what do I get? I'm not going to solve it, just do some trig. So I want to go into my components. Let's go sum of forces. Let's do x first. That's going to be the easiest. So sum of forces in the x. Well, one of the notes I have for myself, I wrote down on this page that it's accelerating. I want to be very clear here. If there isn't a piece of force this way, this thing has to be accelerating, because I have this force that's going to have an x component in the x. I'm sorry, it's going to have a piece of the force in the x. So that means it only has one piece of force in the x. One. That's it. So if I only have force in the x in one direction, that means I have a net force. There is nothing it can do but accelerate. There's no forces opposing this x motion. So my force in the x then is going to be this force applied. Let's see, and I need to turn that into an x vector. So my force applied, if you haven't seen it, this is the x vector, and that would be the y vector. I should have done that in a different color. So please go back, go back and review my trig math prep if this doesn't feel comfortable to you. But so I need this x component of that force applied. This is the adjacent side. That is the angle. So this says that cosine equals the adjacent over hypotenuse. So this force applied times cosine of the angle, cosine of theta, equals, well, this thing is accelerating. So here's a new thing that I'm going to introduce right now, is that says that if it's accelerating, then I have mass times acceleration. I'm going to repeat that. If I have a net force, that mass is going to accelerate. So whatever this is acting on, if I have a net force, I'm causing some mass to accelerate. In this case, I do. What I want to be really clear with you on is that the only time F equals ma is when the darn thing's accelerating. So don't let yourself say that forces always equal ma. It'll make more sense as we move along. So I have a net force, I am accelerating. Let's take a look at the y. So the y is kind of cool here. Let me ask you this. I'm pulling up on it, so you can't really see, but if here I am, and I'm pulling up, and here's my box. Do this. So I'm pulling on it, this, and it's going along the ground. It's kind of like your luggage as you're moving through an airport or wherever. Is you're pulling it, you're actually pulling it up a little bit. So if I'm pulling it up a little bit, what's really interesting is I'm decreasing the impact of the normal. This is going to be important for when we do friction, which with the pace of this class is going to be like tomorrow. So I am decreasing the contact of the normal. Why? Because now I have, this has a y piece to it. I have my force normal because this thing is sitting on the ground, right? I'm just pulling it as it's moving along the ground. So I haven't pulled hard enough to make it shoot up into the sky, and it's not plummeting down to the earth. So what that means is that these two forces, the y component of this applied force and this force normal, must be equal and opposite to the force of gravity. So let's write that out. I've defined up as positive, so I have the force normal. The force normal is all on the y, plus the force applied. And now I want the y component of that force applied. So look at this, the y component is the opposite side. So that is my sine function. So it's going to be the force applied times sine of my angle. Those are my two upward forces. Now I'm going to subtract this downward force. So minus the force of gravity. So when I do that, well, most important other thing that I always require is that after you've done your sum, they must equal something. Don't let yourself get in the habit of not setting them equal to something. Ask yourself, I'm going in the y, is this thing shooting up in the air or falling down to the ground? If the answer to that is no, the sum in my y is 0. Let me repeat that. When I'm doing the sum in my y, when I'm looking at my forces acting on something in the y, if the thing isn't shooting up into the air or plummeting down to the ground, the sum of my forces in the y are 0. All right, let's do math on the next one.